So by now we know for an internal hinge at for an internal hinge, the number of releases are equal to the number of members at the point of internal hinge. There are 2 here minus 1. Thereby what we obtain is 1 release for every internal hinge. Next, if we take first example here, now this is a cantilever here, and there is a roller connection here, then there is an internal hinge here, and this is a hinge here. So the static indeterminacy of this would be alpha. Alpha is the number of actions, there are 3, into the number of members, there are 3 here, plus the number of reactions, there are 6, minus, now beta is the number of equilibrium equations, there are 3, into J is the number of joints, there are 4, plus the number of releases. Now for one internal hinge, the number of releases is 1, so this comes to be 2. Next, if we take another example, now there is a guided there is a roller here, there is a hinge here, and we then have a hybrid joint at this point, then there is a fixed support. Now the static indeterminacy would be again alpha is 3 into 3 is the members, the number of members, plus 6, 2 at this joint, 1 at this joint, and 3 at the fixed one, so total 6, minus, now what is the value of beta? Beta is the number of equilibrium equations, there are 3 here, into number of joints of 4, plus the number of members, the number of releases here, if it's not supported, is 1. So the total static indeterminacy comes to be 2. Next, the static indeterminacy is 3 into 3 plus 8, 3 being alpha, the number of actions, members in action, then 3 being m, the number of members, plus 8 being number of reactions, minus 3 into 4, the same thing. There are 2 additional reactions at this one, at here this is the vertical one and the rotational one, so it becomes 8. Thereby total static indeterminacy here is 5. Now let's come to the trusses. In a truss you have an if this is without these red cords, then static indeterminacy would be determined by the same formula. Alpha is 1 here, because only the axial forces are acting, not the shear force and the bending moment, into m is the number of members, that's 9, plus 3 is the number of reactions, 1, 2, and third one is here at the roller one, minus beta. Now here being the number of equilibrium equations are only 2 in a truss, because these all joints are pinned, the internal joints are pinned, so there is no moment in the equilibrium equations. And J is the number of joints, that's 6 here, plus no releases, it's 0, so the total static indeterminacy comes to be 0. Now if I add 2 more red lined cords or the members of the truss, then the number of members becomes 11 and the static indeterminacy becomes 2. If we want to calculate the external indeterminacy here, it's r minus 3, that's 3 minus 3 equal to 0, and the internal indeterminacy here is static indeterminacy minus external indeterminacy. For the second case, when there are red members as well, is equal to 2. So in beams, the static indeterminacy is equal to external indeterminacy, while in trusses and frames, static indeterminacy is external plus internal indeterminacy.